PyMC uses something called PyTensor to leverage GPU acceleration and complex graph optimizations. Tell us about PyTensor and how this impacts the performance and scalability of Bayesian models.
Yeah, yeah, great question. So basically, the way PyMC is built is we need a backend, and historically, this has been a complicated topic because the backend, like, then we had to do the computation. Like, otherwise, you have to do the computations in Python, and that's slower than doing it in C, for instance. And so we have still that C backend. That's kind of a historical remnant. But more and more, we're using, and when I say we, I don't do a lot of PyTensor code, to be honest. I mean, contributions to PyTensor. I mainly contribute to PyMC. PyTensor is spearheaded a lot by Ricardo Vieira, a great guy, extremely good modeler. And basically, the idea of PyTensor is to kind of outsource the computation, basically, that PyMC is doing. And then, especially when you're doing the modeling, the sampling, PyTensor is gonna delegate that to some other backends. And so now, instead of having just the C backend, you can actually sample your PyMC models with the NumPy backend. How do you do that? You use another package that's called NumPy, that's been built by Adrian Zabelt, extremely brilliant guy. Again, I'm like surrounded by guys who are much more brilliant than me. And that's how I learn, basically. I just ask them questions.
That's what I feel like in my day job at Nebula, my software company. I'm just
Yeah.
like, wow, like, yeah. Anyway, sorry, I'm just completely interrupting you.
Yeah, no, same. Like, and so yeah, so Adrian basically re-implemented HMC with NumPy, but using NumPy and Rust. And so that goes way faster than, just using Python or even just using C. And then you can also sample your models with two other backends that we have that's enabled by PyTensor, that then, basically compiles the graph of the model and then delegates these operations, computation operations, to the sampler. And then the sampler, as I was saying, can be the one from NumPy, which is in Rust and NumPy, and otherwise it can be the one from NumPyro. Actually, you can call the NumPyro sampler with a PyMC model, and it's just super simple. Like in pm.sample, you just like, there's a keyword argument that's nuts_sampler, and you just say NumPy or NumPyro. And I tend to use NumPyro a lot when I'm doing Gaussian processes, because I don't know why, but so most of the time I'm using NumPy, but when I'm doing Gaussian processes somewhere in the model, I tend to use NumPyro, because, like, for some reason in their routine, in their algorithm, there is some efficiency they have in the way they compute the matrices, and GPs are basically huge matrices and dot products. And so yeah, like usually NumPyro is usually very efficient for that. And you can also use JAX now to sample your models. So we have like these different backends, and it's enabled because PyTensor is that backend that nobody sees. Most of the time, you're not implementing a PyTensor operation in your models. Sometimes we do that at PyMC Labs when we're working on a very custom operation, but usually it's done under the hood for you. And then PyTensor compiles the graph, the symbolic graph, and can dispatch that afterwards to whatever the best way of computing the posterior distribution afterwards is.